Hello student, in this lecture we learning the current gain of a transistor. So basically the transistor is a current control device, not a voltage control device. So in this lecture we learning the current gain of a transistor. So first, what is meant by the current gain? So current gain is nothing but the ratio of output current to the input current, and depending on the different configuration of the transistors, the transistor have the three current gains. First one is current gain for the common base, that is alpha. Second is the beta, and third one is gamma. So the first, that is current gain in the common base configuration. So in this configuration, base is the common for the input section as well as the output section, and we require the output current and the input current. So what is the output current for this section? So base is the common, this is the collector terminal, and this is the emitter. So in this configuration, IE is the input current, emitter current, and IC is the output current. So IC is nothing but the output current. So we can write the alpha is nothing but the output current, that is output current is nothing but the IC divided by the input current, that is nothing but the IE. So again, next for the current gain for the C, that is common emitter configuration. So this is a common emitter configuration, and in this configuration, emitter terminal is the common for the input section as well as the output section. And in this section, the input current is nothing but the IB. So this is nothing but the input current IB, and output current is nothing but the IC. So we can rewrite the beta is nothing but the output current IC divided by the input current IB. And again for the similarly, the here is a collector terminal is a common because this is the emitter terminal. Arrow indicates the emitter terminal. So in this section, the collector terminal is common for the input section as well as the output section. And in this configuration, so IB is the input current and IC is the, and IE is output current. So IB is the input current and IE is the output current. So IE divided by IB is the current gain in case of the common collector. So note down the alpha is always less than 1. Why this is? Because if you look the structure of the transistor, and in this structure of transistor, so this is the emitter, this is the base, and this is the collector. And if you apply some voltage in such a way that the first junction is forward bias and second junction is a reverse bias. So in this case, so suppose this is the PN transistor. So emitter current is entering into the emitter, and out of that, suppose the 100 electrons enter into this emitter terminal. So this is 100. Out of 5%, 4%, that is a 4 or 5 electrons recombine with the holes and forms the base current. So that is the IB is nothing but the 5. IE is equal to something 100. And out of the 100, 5 goes here, and remaining 95 forms the collector current. So this is nothing but the IC. And if you take the ratio, that is IC 95 divided by the 100, so we get the 0.95. So always remember that whatever maybe electrons comes into the emitter, out of the 2, 3, 5% combined with the holes of the p regions, and they forms the base region. So remaining electrons goes into collector and forms the collector current. So collector current is always less than the emitter current, or we can be saying that the IE is always greater than the IC, but it may be the approximate to the equivalent. Approximate. Again, similarly, the base current gain for the CE configuration beta. This is the IC. So IC is always the greater. So this is nothing but the 95 and this is 5. So beta is always greater than the 1. We can say it. Okay. Now next point is the relation between the alpha and beta. We deriving the relation between alpha and beta. So we know that the basic equation of the transistor, that is IE is equal to IB plus IC, that is emitter current is equal to sum of the base current plus collector current. And if you divide this equation by IC, we get the IE divided by IC is equal to IB divided by IC plus 1. Also we know that alpha is equal to IC divided by the IE. Again, if you arrange this equation, so we can get 1 divided by alpha is equal to IE divided by IC. That means we can rewrite IE divided by IC is equal to 1 divided by alpha. Similarly, we can rewrite the beta in the form of the 1 divided by beta plus 1. So this is again 1 plus beta divided by beta. If you arrange these equations, so we get the value of the alpha. So alpha is equal to beta divided by the 1 plus beta. So these equations give the relation between the alpha and beta. Again, if you arrange this equation for the beta, so 1 divided by beta, and this positive comes here, it becomes the negative, that is 1 divided alpha minus 1 is equal to 1 minus alpha divided by alpha. So again, if you arrange, so we get the value beta is equal to alpha divided by the 1 minus alpha. So these two equations give the relation between the alpha and beta. Once you know the value of the beta, we can define the value of the alpha. And if we know the value of the alpha, we can define the value of the beta.